Hello, everyone. Welcome to the webinar today. Looks like some people are funneling in, so we'll wait a second or two before we get started with the presentation. Thank you so much for joining us. I did want to let everyone know that we are recording this session today. We will be emailing out the recording and a copy of the slides so that everyone can have that to reference and to share with your colleagues. We also will be taking questions throughout the webinar, so if you have them, please submit them in the comments section or in the Q&A section, and we'll be sure to get to them throughout the presentation, or there'll be time at the end. And with that, let's go ahead and get started. Let's introduce our speaker for today. Our speaker today is Dr. Tim Oates. Tim is the co-founder and chief data scientist at Synaptic, with over 20 years of experience in guiding organizations and companies of all sizes, applying AI and machine learning to business problems across industry. Dr. Oates earned his PhD in computer science from University of Massachusetts Amherst with a focus in AI and machine learning, and was a postdoctoral fellow at the MIT lab. Thank you so much for joining us today, Tim. I will let you take it from here.
Okay, thanks, Sam. I appreciate it. So I just want to start out with a real quick slide about Synaptic. We started eight
And
years.
Tim, I think we lost your presentation maybe. Do you want to try to share it again?
Oh, really? Oh,
Oh, there it is. It's back up.
hold on. Can you see that?
Yep, we can see it now.
Okay, good. Thank you.
Yeah.
Um, so anyway, the company started, I don't know, 8, 9 years ago, focusing on applying machine learning. It was a lot of kind of modeling and predictive analytics and things like that. Over time, though, we expanded to kind of doing things that were more AI, machine learning, and then more data engineering. And as time went on, we realized that there were a lot of opportunities for integrating that into product scenarios as well. So beyond just companies saying, hey, we'd like you to build this point solution so we could predict this thing better, so we could make more money, they would want to put it into products. And so through time, we got experience in product design, user experience. And so we try and kind of span the whole gamut from hardcore AI ML kinds of things, which is what I like to do, to scaling up and big data, to actually putting these kinds of tools in front of users. So anyway, here's the outline for today. This is actually, I do these webinars with some frequency, and this one I think is kind of interesting. I enjoyed putting it together. So we're going to focus on food and beverage, and I've got some case studies here, a couple of them that we've done. So I'll talk about extracting information from restaurant menus, which has a really interesting purpose to it. We've looked at doing shelf analytics, so thinking about looking at the contents of shelves in grocery stores and things like that. And then, I found some interesting work that's been done recently on improving flavors using AI to do that. And then it turns out that predictive maintenance is actually very important in the food and beverage industry. So I'll talk about those things. And then, you can't talk about doing modern AI without thinking about large language models like ChatGPT. So what you'll see is that some of those early case studies were done by us several years ago when the technology was very different. And there were sort of machine vision based kinds of problems. And what I did as I was putting this together was I was like, wow, could ChatGPT do that today? And how well would it do? So I actually did a sort of grab some data and did a couple of quick experiments. And we'll see sort of the older approach and the newer approach and kind of contrast those things. And then I'll wind up with some concluding thoughts. So, I can't see anything but my screen, but if anyone has questions, please feel free to interrupt me. And I think Sam will go, hey, there's a question, and read it out to me. So I did want to start with this, though. I thought this was an interesting statistic. This is AI in food and beverage globally. And so this report came out in 2025 and looks like about 13 billion was spent on AI initiatives in food and beverage, and it's going to go up to 30 billion by 2028, right? So this industry segment, as I think hopefully you'll see in my presentation, is a great one. There are a ton of opportunities for applying artificial intelligence in the food and beverage industry. So the first one I'll talk about was a really interesting problem we worked on some years ago on extracting information from menus. So we were approached by a food supplier. And so these suppliers, they sell restaurants in units of cases, as I came to know. And there are lots of people that are in that business. And as you can imagine, there's this very long tail. They're going to be chains, but then there's a kind of long tail of individual restaurants that need to buy food, and they buy a lot of it. And so the interesting thing that this company was thinking about was, all right, I'm selling this many cases of fruit, for example. I believe that's fruit in those cases there to this restaurant. Um, how much fruit are they buying in all? Could we get more of that business? And what other kinds of foods are they buying? And could we maybe grab that business as well? So the idea was they'd like to get a handle at scale on what products restaurants need, individual restaurants need, and then they could look at what fraction of the business do they have and can they potentially grow that business. So that's the problem. It makes a lot of sense. They, I will say, had the following very good idea. Oh, sorry. So, we're selling fruit, but maybe they buy shallots and we want to be able to sell shallots to them. So they had this really interesting idea, which was, what if we look at their menu? So, my experience with a menu is I roll into a restaurant, I'm hungry, I'm looking for the thing that I want to eat. But it turns out, if you think about it, that if you look at the menus closely, they contain an enormous amount of information about what ingredients they might be using and in what quantities, maybe not sort of the restaurant as a whole, but sort of relatively, how much of the quantities am I using of these things? And so the good news for this project is that menus are available online. Restaurants want you to find them, right? They want you to go online, look at the menu, look at the food, and then think about, what would I want to go to this restaurant? What would I eat there? So the idea was if we could scrape menus at scale from the internet, we might be able to do things like figure out what dishes the restaurants are serving, what the ingredients are, and what the prices are. And so you can see that there might be a lot of really valuable information in there. So, if you just look at this is a random menu that I found on the internet. I have no idea. It's in North Wildwood. Anyway, um, like what can you learn from a menu? You can look at this thing and go, oh, well, they use a lot of different kinds of cheeses. There's American cheese and blue cheese, and there's provolone cheese, and actually American cheese is used in like several of their cheesesteaks, right? So the idea was, is it possible for us to take a menu just like this that we got from the internet and walk over it using AI techniques to identify what are the dishes that they serve, what are the costs of the dishes, because that might give us some idea as to, how much money the restaurant is making, and then what are the individual ingredients. So how did we frame this problem? Again, this was done a few years ago, so we thought about treating it as an object detection problem. So let me just talk for a minute about object detection on this slide, and then I'll show you how that applies to extracting information from menus on the next slide. So what's object detection? The idea is that I get pictures and there are things in them that I want to find. So maybe I want to find people and bikes and cars and traffic lights. So the way you build an object detection system is you create training data. So I'm going to get pictures and I'm getting a human to go in and like literally draw a box, right? Oh, inside this box, there's a car. Inside this box, there's a person. Inside this box, there's a traffic light. Then what you would do is you would take that manual annotation. You would use a thing back then, we would train a neural network that were specifically designed for solving this object detection problem. And what they do is once you've trained this neural network, you can show it a new image and it'll go, oh, here's a box in the image, and I think the thing inside that box is a car. Here's another box in the image, and I think the thing inside that is a truck. So, you know, at the time we were doing this, object detection systems were becoming increasingly powerful. And the way we thought about solving this problem, and we indeed actually built, was to treat it as an object detection where we're finding things in pictures of menus, right? So we actually trained it in kind of an interesting way, which was he said, hey, let's build an object detector for menu items. And that is, here's a menu item. So we're going to put a box around that thing and go, oh, typically it's going to contain the name of the dish. There'll be some numbers in there, and those numbers can be interpreted as prices. And then usually there's a list of the things that are in the dish, right? Because you want to know, like, what's going to be on this thing? Do I want all those ingredients or not? And so we started out by saying, let's build an object detector for menu items, which are exactly this kind of thing, right? Now, once you've got the menu item, you can do things like say, hey, can I identify a sequence of numbers in there that look like a price? And can I also find lists of things that look like ingredients in there, right? So basically, the idea was let's build a thing that will just put boxes around all the menu items. And then once we've got a menu item, we can kind of pull that out and do more fine-grained analysis of what's going on in there. So the question is, why is that hard? And it turns out that it's pretty hard. One is you got to do this sort of like web scraping at scale, right? You want to be able to go grab menus um, and then there's this amazing variation in menu styles, right? There's a menu from a American Chinese restaurant, and then there's a breakfast menu there. And so, in the menu, the breakfast menu turns out that the text is sort of running across the pictures of the food, the layout's different, and so there's tons of different fonts. The layouts are weird. And you and I look at one of these things, and it's very easy for us to look at it and go, "Oh, this is how you solve that problem." But that level of variation meant that you needed lots of training data. The other thing is that they're mostly images. They're not like PDFs. So if you've got a real PDF that was generated from source, it's easier to pull the text out of it. These things were just images, like pictures of menus. And then you have to wind up doing optical character recognition. And that's just much, much harder to do. So what we wound up doing was using a lot of background knowledge. So, the company had a list of known ingredients, right? So, like provolone cheese is an ingredient that you tend to see in menus. So, if the OCR system extracted praline cheese or something that was close to it, you could go, I bet it matches to provolone cheese. So, this sort of being able to check against background knowledge was important. There are also common price ranges. So if I see a dish that's, $1,199, maybe it's actually $11.99. You can use the type of cuisine. If I know it's an American Chinese restaurant, that will bias me that certain ingredients are going to be more common. And then, fortunately, these items tend to have a standard layout, which is sort of name of the dish, price, ingredients. So basically, we tried to bake a lot of information into that thing. So the solution looks sort of like this. We'd have a scraping engine that retrieved the menu. Turns out even if I just point you to a restaurant's website, you got to be smart about kind of walking over that to find out where the menus are in the website. Then we would download the raw menu and store it in a database. And the reason for doing that is we're going to kind of future proof against model improvements, right? So the idea is we don't want to like grab the menu, run the extraction on it, and then throw the menu away because creating these models tends to be an iterative process and you're going to make improvements to them. And sometimes you'll say, okay, I think it's way better now. Let's go run it back across our original data set. You don't want to have to go back to the web to scrape that stuff again. So then we create training data, build models, we extract the menu items, and then within the menu items, we'd find the ingredients and the prices. And we would sort of use this sort of logic to verify this background knowledge to verify that what we were doing was the information we were extracting was accurate. And then we store the results in a database. So we built that solution, worked well, and the company took it over and started using it. So again, that was some number of years ago. So then I got curious and I thought, well, could ChatGPT do it for me? Right. So what I did was I just went to ChatGPT 4.0 on the web, publicly available, and I gave it this prompt. I said, please look at the menu in the link below and extract the names of the dishes that are on it. And I'm using Owen's Pub menu, right? Like if you go to owens.pub/menu, that menu is going to pop up. And it goes, here are the dishes listed on the menu at Owen's Pub. And I thought, wow, that's amazing. But then I started looking at it and I was like, they do not have mixed pakora with homemade spiced onions. So I have no idea where it got that thing from. Like I went to owens.pub/menu. I was all over that website. There was no mention of like any of these dishes anywhere. So I have no clue what ChatGPT was doing. So I thought, okay, let me be a little bit more specific. So now I went to Owen's Pub, even though I spelled it Onan's Pub, misspelled. But anyway, I got the menu and I said, what are the names of the items in this menu? Then it's clearly paying attention to that particular menu and it does way better, right? There's the Owen's cheesesteak, the cordon bleu cheesesteak, the black and blue and bacon. So it does a really good job of finding the items. And then I said I'd like to ask a couple of questions about the American cheesesteak. And it goes, of course, what would you like to know about the American cheesesteak? It's, ChatGPT is always so enthusiastic. I said, how much does it cost? And it goes, it's 11.99. Would you like me to also tell what's included in it? And I said, yeah, yes, what ingredients are listed? And then boom, it gives me the list of ingredients, right? So um, just like evidence that if you wind up using a tool like ChatGPT, it can be incredibly powerful, but you have to be careful. And we'll have a little bit more to say about that in a minute. So anyway, one application of AI, sort of old school machine vision, new school. Let the large language models sort it out. Um, Another project that we looked at briefly with a client was shelf analysis, and it sort of looks like this. So, interestingly enough, there was a relatively recent article from 2024 about Simbi Robotics. So you can see here's a grocery store shelf. Here's this little robot. And what it's doing is it's just going to sort of walk down the aisles and get imagery, right? So the question is, why do you want to know what's on a grocery store shelf? And there are lots of reasons. And actually, we've talked to a couple of companies about this kind of problem. So one is you just want to know when things are out of stock, right? So if things are missing, if there are products that aren't there or they're running low, you got to restock it so that you don't lose those sales. It's also the case, and I've learned this from talking to companies in this space, that if I'm a producer of things that are on grocery store shelves, I actually am going to try and get prime placement for my product, right? I don't want it to be on the bottom shelf along the floor. I want it to be kind of right at eye level. And so grocery stores build out these things called planograms, which is a term of art, again, as I learned, which is just like a shelf layout design. And so the idea is that if I'm a supplier, I'm going to make an agreement with you for my product placement. And if I'm a supplier, I want to make sure that you're abiding by that, right? If I paid you a little bit extra to my product at eye level, it better be at eye level. So you also might want to monitor pricing accuracy, optimize inventory and supply chains, right? So I really want to sort of, as things start getting low, I want to make sure that I have enough product on hand, plan deliveries so that I can keep the store shelves stocked. And then, maybe I want to gather competitive intelligence. Like I'm grocery store A and I want to know what's going on at grocery store B. And this happens all the time. There's actually another company that we talked to. Unfortunately, we didn't work with them, but they have an app where they crowdsource this. Basically, it's an app, and you can download the app, and then you can get tasks. And the task might be, hey, there's a 7-Eleven 2 miles from you. I'd like you to go take a picture of, I don't know, caffeine-free Diet Coke, right? Just find it in the store and take a picture of it, and we'll pay you a little bit of money to do that. So, a lot of interest in this particular problem. So the question is, why is that hard? And it turns out that it's really hard. So there are a lot of variants of the same product. So here, for example, there must be, I don't know, 6 different kinds of Doritos there. And I don't know about you, but I personally find it very frustrating when I go to the store and I come back and I like pull the Doritos out. My wife is like, why'd you get the flaming hot Doritos? And it's like, I didn't mean to. It's like they look identical to regular Doritos, right? So there are these like very similar packaging with subtle cues as to the difference. It's also the case that customers, put items back in shelves in the wrong places. And then there are things like somewhere in here, right. So here's some popcorn, and notice that there's a package here and a package here and a package here. That one is kind of laid back. It's occluded. It's a little bit hard to see. You know, do I need to know if it's the 5 ounce or the 7 ounce package? And then a human, if you're solving this problem, if I said, hey, like, can you just go gather all this information for me? you're going to get like really close to the, you're going to look over, scan the shelf and sort of move back and forth. Static pictures are less useful. And then a monster problem here is that there are a very large number of SKUs, right? So the number of individual products that you have to deal with can be very, very high. So hard vision problem. Okay, so how do we do it? And this is going to sound familiar. So we treated it as an object detection problem, right? Where the objects that we're learning to recognize are products that can be placed on store shelves. So the sort of interesting thing that we did here was we used what's called few shot training. And so as I, mentioned previously, to build an object detector, you want to have examples, right? So like I'm going to go, oh, there's a Cool Ranch Dorito there. There's a Cool Ranch Dorito there, right? So in this little box, there's an example of that thing. Typically, machine learning systems need lots and lots of examples to learn something well. But if I've got hundreds of thousands of things that I need to be able to recognize, I can't build that training set, right? I can't get images of those things. And so there are methods in machine learning, which are called few shot, where what you do is you go, here's one example. Please learn to recognize that in lots and lots of different situations. So we used, basically images from the web. You could say, hey, here's a picture of Cool Ranch Doritos from the manufacturer, for example, on their website. Now use that one image and be able to detect it on a store shelf. Also, you have to use domain knowledge. So typically similar products are grouped together, right? There's a bias which says, oh, if I found Cool Ranch Doritos, I bet it's more likely that Cool Ranch Doritos are to the left and the right of me as opposed to being far away from me. Also, they tend to be in blocks, right? So I might have things sort of on the shelf here and a shelf here, but as I get further away in shelf space, it's less likely to be the same product. And then color changes are important, right? So if I'm scanning left to right or up and down, if I see color changes in the products, I'm seeing those are cues that things have gone wrong. And in this case, having a human in the loop to correct mistakes is going to be super important. So having a human looking at it and go, yeah, that's not Cool Ranch Doritos, that's just regular Doritos or whatever, and feeding that back in is going to be important. Okay. So then what I did was I said, okay, like very hard problem. Again, this was done some number of years ago. Let's see if ChatGPT can handle this particular problem. So I just uploaded that image and I said, what products were shown in the image? And it gives me this narrative. It's like snacks, different brands, chips. So Doritos, various flavors, Cheetos, Ruffles, Lay's, Fritos, Sun Chips, Smart Food, popcorn, right? So that's fine. Then I said, how many bags of Cool Ranch Doritos are there? And it goes, well, looking closely at the image, there are 8 bags of Cool Ranch Doritos visible on the shelf. They are in the top row, packaged in blue bags, right? And so there's actually one, two, three, four, five, six, 7 of them, right? And so like the numbers off, it knows where they are, right? It goes, oh, they're blue bags, they're on the top row, but it's not doing the counting correctly as far as I can tell. Um, and furthermore, it says that they're in the top row. They're on the top and the next row below it. So I said, what shelves, plural, counting from the top of shelf 1 are the Cool Ranch Doritos on? And it goes, well, they're on shelf 1 counting from the top and they're on the left side, right? So it's interesting because it's counting, like it knows there's more than just one, two, three, four, but it's like really not kind of nailing that sort of space as to where those things are. So what are some of the lessons from ChatGPT? I think it's important to keep in mind with large language models like the GPT family that just out of the gate, they'll do these amazing things, right? You look at that, and it's just like when I extracted the items from the menu the first time. I went, oh, that's amazing. But then I looked closer, and there were definitely some issues. So mistakes that it can make can be subtle, right? Like 8 versus 7 bags of Cool Ranch Doritos. They can be hard to find, especially if you're doing it at scale and like harder to fix. So the idea is that with large language models, yeah, trust but verify. And sometimes like being much more sophisticated about the prompts can be helpful. So, you could say, hey, where are the Cool Ranch Doritos? And then when it tells you they're on the top shelf, you can do things like are there Cool Ranch Doritos on any shelves other than the top shelf, right? So you can sort of like probe it and poke it and say, could you think about that a little bit more and tell me if you believe it? Or you'd have two LLMs in a sort of a feedback loop where one extracts information, you hand it to another one and go, hey, what do you think about that? And have some back and forth between them. So I didn't know, I didn't go deep enough into this particular problem to try and sort that out, but those are the kinds of approaches that you would deal with. So uh, next topic is improving flavors. And this is one that I found as I was preparing for this webinar. Um, Kind of amazing. So turns out that in Nature Communications, very well-respected journal, there was an article predicting and improving complex beer flavor through machine learning, right? So I thought, okay, like great topic. Let's talk about that. And if you want to, there's a lot of public press about this thing, right? So researchers in Belgium use artificial intelligence to improve taste, but say the skill of the brewer remains vital, right? Which is I like it when I see those kinds of things. AI can be an amazing force multiplier, but in many situations, you still need that human in the loop to make things work. So what did they do? And it makes perfect sense, right? So they had 250 commercial Belgian beers, 22 different styles. And so what they did was they got a bunch of quantitative data. So lots and lots of features of each of the beers. They looked at alcohol content, pH, sugar concentration, the presence and concentration of like more than 200 different compounds involved in flavors, right? So, and then lots of other features. So what they did was they said, let's take this beer and extract a bunch of information that we think is relevant to how people are going to perceive the quality of the beer. Then, given that, they got some qualitative data. So they got 16 participants. They sampled and scored each of the 250 beers. This apparently took quite a long time. I feel like the article said it might have taken 3 years to do this. So they had 50 different attributes that they were having the people rated on, like hop flavors, sweetness, acidity. So they had what I assume it wasn't just sort of weekend beer drinkers like me. It was probably people with more sophisticated palates who sort of went in and said, like, here's sort of what we feel is going on with that beer. And then they got 180,000 reviews of different beers online, right? So now with the quantitative data and the qualitative data, what I want to understand is what's the relationship between kind of the chemical composition of the beer and what people think about it. And so this is an example of supervised learning. And I realize now that I've hit this slide, I've already talked about supervised learning a little bit, but let me just talk about it in like a little bit more detail because it'll be important on the next slide. So um, supervised learning is where I have things like email messages and they're labeled by type, right? So in the picture here, we've got email messages are the things, we've got some that are important, and we've got ones that are not necessarily important, right? So it could be I've got email messages and a human goes important or not important. We could have beers and will consumers like it, right? It could be audio from an HVAC system running, and I'm trying to figure out is the compressor bad or not, or data about employees and do I think this person is headed for the door in the next 6 months, right? So supervised learning is all about taking things, extracting information about them that you can hand to a computer program to do learning to make a prediction about that thing. And so for beer design, what they did was they extracted information about beers. And then what they did was they trained a model and a neural network. I confess I didn't actually see what kind of model they were using. And the neural network is producing an output, right? And so maybe what it's doing is it's saying, okay, that particular beer, characterized by these chemical properties, was rated as a 7.5 out of 10 by the people at a beer review site, right? Or our 16 people that tasted the beers sort of thought it was a 7.5 out of 10. So that's fine. Then the question becomes, how do I make my beer better? Then the nice thing is now that I've got a model that can take chemical properties of beer and tell me how good it is, like what the qualitative measure is, I can then start imagining what would happen if I increase the pH of the beer to 4.3, right? Now, I'm not actually going to go increase the pH, what I'm going to do is just go, oh, for that beer, I'm just going to change the pH number. It used to be 4.1. Let's pretend it's 4.3 and pass it through the model. And so if the model goes, oh, well, that's a 7.7 out of 10, then you go, oh, well, increasing the pH is actually going to produce a beer that people like better. So what they do then is they just start kind of tweaking the values, right? So if we change the chemical composition of the beer in this way or that way, or if we increase this much of the hops, or if we got more of this flavor compound in there, it would actually be better. So super interesting use of a trained model that tells you an outcome that you care about, and then doing this kind of what if analysis. What if we change the thing that we give you? Would the qualitative outcome improve or get worse? And so now you can start designing beers in this case, or foods that have flavors that people are going to like more. So lots of other uses. You can predict flavor profiles to optimize recipes. You can imagine doing personalization of flavors, right? So this consumer segment, we're going to sort of optimize it for that segment or this segment. You can think about controlling fermentation to make it consistent, detecting and correcting off flavors early in production, or even trying to kind of simulate new flavors virtually just to speed up R&D. So lots and lots of articles out there on the use of AI to help sort of understand how to improve the flavors of foods or beverages, beer in this particular case. Okay, so the last one I want to talk about is predictive maintenance. And so I've actually, talked about this topic in other webinars that I've done, but it turns out that it's super important in the food and beverage industry. So, I'm sure we've all seen videos of production lines in food and beverage, and you've got these conveyor belts with product on them that are moving incredibly fast. And so, faster production with high-speed machinery means you're going to get higher wear. It's also the case that customers expect, like, if I buy Doritos today, I want them to be exactly the same tomorrow, next week, and next month. So your machinery needs to be producing very consistent results. You also have to think about regulatory compliance in the food and beverage industry. And then there's a lot of cleaning and sanitation. So, waters and chemicals cause corrosion. And, anytime you're in an environment like that, things can break down more. And then even sort of outside of the machinery that is directly involved in producing the food and beverage, you can have things like HVA systems, right? So if your chiller goes down or your HVA system goes down, then that downtime means you can't be producing the product, and maybe there's going to be raw material waste, right? So it's just like electricity goes out in your house, your refrigerator's dead for 4 days, you got to throw all the food out, right? So sort of it's all over the place in the food and beverage industry. So I'll just talk about it a little bit to kind of give you a flavor for how predictive maintenance goes. So there's preventative maintenance, which is I've got some thing that's being used in a food and beverage production line. Um, and there's like, no need for maintenance. I could do some maintenance on that. Just I could oil it or whatever. At some point, though, things start happening. So if you talk to people who work around machinery a lot, they'll go, that thing doesn't sound quite right. Like it's making a funny noise. Or you could have sensors on there that are, for example, like vibration or ultrasound sensors. And then eventually you can see weird behavior in the power draw of these things. And then eventually it gets to be loud. Like anybody who walks in goes, that thing is making a very bad noise, or it smells bad, or it's running really hot, and it breaks down. So you've got preventative maintenance, which is I'm just going to do the routine kinds of things. You've got reactive maintenance where it's like it's completely obvious that you need to do something. And then predictive maintenance is trying to look for subtle cues and deal with them so that you can kind of keep that machinery going for longer. So lots of ways to do it. Here's an example of a project that I worked on where we had a data acquisition system that produced binary values from sensors every 1 millisecond. And so they're just these little switches, right, that are controlling a thing. And so turns out that, sometimes a switch will go from a closed state to an open state. And if that thing just goes boom, okay, I've transitioned, that's good behavior. And it turned out that the experts who worked with these systems said, well, if it does this thing, which we're calling chatter, which is like it's trying to transition and it takes it a little while longer than like eventually it transitions, but there's a little sort of like up and down going on in there, that's bad. So you could take the supervised machine learning approach, which is you get your human experts to say, oh, well, that sensor on that particular piece of equipment, yeah, that's working well, or it's not working well. And then train up a model that can take a new reading from that sensor and go, yeah, that piece of equipment is fine. We're good to go. That's one approach. You could also just do it as anomaly detection, right? And so the idea is that if in general your systems are going to be up and running smoothly, which is what you would expect, you can gather data. And then when something comes in, you can go, oh, well, let's look at that. Is that the same or is that different, right? So if it's the same as what we see routinely, then it's probably okay. And to the extent that it looks very different, we, maybe need to take a little bit of a closer look at that. So just, in considerations for doing predictive maintenance, the way I think about it is, again, if you've got that person who's worked with that equipment for 40 years, and it doesn't have to be 40 years, but you got somebody who really knows that equipment inside and out. If they have the ability to kind of look at it and go, something's not right, then, I think it's feasible to think about um, an AI system solving the same problem. Now, it doesn't have to be that case. It turns out that, for example, people can detect or systems can detect faults in concrete, for example, by using infrared sensors, and human can't do that. But again, like a nice rule of thumb is if, Joe or Jane, who's been working with that equipment forever, like feels like they have a seventh sense for it, good possibility that you can build a machine to do it. What you have to think about is what's the ROI? What's the cost of downtime? If I have to add instrumentation and then store data, how much is that going to cost? And then, what gains do I expect? I'm going to have increased uptime because I'll like take it out of service for a little while, do some maintenance and put it back up. What is that going to get for me? And then think about the approach. Am I going to look for things that are weird, anomalies? Am I going to do supervised learning? Or sometimes just having an expert look at a plot of like, here's some vibration data coming from that thing. They go, oh, yeah, you see it's getting worse through time. We need to do something. Okay, so what are just a few concluding thoughts? So, again, the future looks bright for artificial intelligence in the food and beverage industry. Tons of other applications out there. So, inventory management is important. Waste reduction. So, there's a lot of food that goes to waste, especially in the United States. But how do I reduce waste in the food and beverage industry? Supply chain is a big issue, right? I have to get fresh things to my restaurant, for example, in a timely manner. And then quality assurance is really important when it comes to food and beverage. So that again, the sort of consistency, but making sure that there aren't other kinds of issues that could lead to harmful effects for people who consume it. And so, how do you get started? This is actually very generic in some sense. It's not just for food and beverage, but I see the schema play out a lot. So, sort of think about what are your pain points, either internally, like our production lines are always going down, or externally, our customers are always complaining about the olives for some reason. Then I would say work with a trusted partner to explore feasibility. Certainly, we do that kind of thing, but I think what you have to do is you've got to go to somebody who understands sort of AI, machine learning, and applications. It's going to be hard to find somebody who's a food and beverage AI expert, although maybe if this trend continues, there'll be lots of them running around out there. But typically, people who are experts in this kind of consulting are very good at kind of listening to the domain experts and then figuring out how to put the two levels of expertise together. Here's the domain, here's the AI. Let's solve a problem. Then you got to think about what's your data look like. So that tends to be the number one blocker for people. It's like, oh, our data's, stored in 18 different spreadsheets on different machines maintained by different people. And then is the technology ready for that problem? It turns out that now is a really, really good time to be solving problems in the food and beverage industry. As you saw, ChatGPT really good at doing some of this stuff. The issue is if I want to scale it up, how do I do that in a way that's going to be maintainable and cost effective? And then look at ROI. So I think in a lot of industries, and sort of the tech industry, it's easy to go to the C-suite and say, hey, we should be using AI to solve this problem. Other industries where AI isn't as common, you tend to have to work a little bit harder. And we've seen that in construction, for example, where people are excited about it, but they're like, oh, I don't know, are we really going to get the ROI that we're looking for? So pay attention to that. Okay, thank you. I appreciate you listening. I'd be happy to take any questions if there are any.
Thanks so much. No questions have come in yet, but a couple of comments in the Q&A. Just, yeah, commenting. Thanks for the presentation. Good information. Some good case studies highlighted there.
Okay.
If you will wait another second or two to see if any questions are popped in. But I hope, thanks again, Tim. I hope everyone enjoys their day. And again, we'll be sending out an email with this recording and the slides for you to reference and share with your colleagues. Thanks so much. Bye, everyone.
Okay, thank you. Bye.